Okay, now I'm recording. All right, does that make sense? So sometimes we can go backwards too. All right, let's look at this one. Body temperatures of adults are normally distributed with a mean of 98.6 and a standard deviation of 0.73. What temperature represents the 90th percentile? So we're looking for the x. What's my mean? Okay, my standard deviation. Okay, and this time they gave me the percent is 90%, right? So I'm looking for 0.9000. And what z-score is going to give me that? Is that the closest one? What about 0.8997? So the reason, so it's, you did exactly what normally would you do. It's like, okay, I'm looking for the 90s. I'm looking at the 90s. So this is going to come up quite often. A lot of times the number that you're looking for will not be exactly there. Okay, so you want to find the closest one to it. So in this case, we've either got the 0.8997 or the 0.9015. The 9997 is closer. Okay, so I'm going to take that one instead. So it's going to be 1.28. So that's my z. So I've got 1.28 equals x minus 98.6 over 0.73. So first step, multiplied by the 0.73. So I've got 0.9344 equals x minus 98.6. And then we add the 98.6. Then we get 99.5 equals x. So, anybody remember the horrible COVID years when everybody walked in, they had to scan your forehead? What number did they use to determine if you could come in or not? It was not 98.6. It was 100.
Really?
It was 100. If you were over 100, they would let you come in. Okay, so what's the percentage of people that would, based on what we did, because this is 98.6 and the standard deviation 0.73, what is the percentage of people that have a normal body temperature that's 100 or higher? Find it. There's no guessing. We can actually find the exact number based on this information. So everything is staying the same on the screen except for I gave you one different piece of information. I'm telling you that the body temperature is 100 degrees. So I'm giving you the what? Nope. I'm giving you the x. The mean is 98.6. The standard deviation is 0.73. I'm telling you X is 100. And we want to find the percent. So we're doing the opposite. We're doing the way that the original way, right? We're not going backwards in this case. So if X is 100, what's the percentage of people that would be excluded from that? What do we get? Very good. So my Z, I'm doing 100 minus the 98.6 over the 0.73, which, if my calculator was correct, I got 1.92 for my Z score. And if you look up my Z score 1.92, we get 0.9726. So if I wanted greater than that, so 0.0274. So I heard less than 1%, but it's actually almost 3%. So to begin with, those little guns were absolutely horrible. I don't know, can't tell you how many times they walked in and they told me my temperature was like 95 or 96 degrees, which would not have been good. But there is a group of people in the population that their temperature is over 100 degrees. Okay. So that is a possibility. Okay. But that's what they used. It's 100 degrees. All right. Remember these two formulas? So this was the expected value in the mean and the standard deviation of those binomial experiments that we did. Now, when we were looking at it before, my binomial experiments were discrete, correct? So there were specific bars. We were able to calculate out the percentages and stuff like that in. So if we go back, let's look one up real quick. Hold on. That's not what I want. Sorry, I'm trying to find the actual problem real quick from when we did it before. Oh, that was what I did. Remember this problem? Okay. So this was the binomial distribution. So assume the plane was the 15 people on the plane. How many people are not going to show up? So we did this one using that formula for it to figure it out. This was a small enough amount of people and values that was easy for us to be able to do. However, if we're looking at hundreds of people, if we're looking at, say, a Boeing 737 that holds like 300 people, that might be a little bit different to do and be able to do these calculations out. So we want to come up with an easier way to do it that's going to be straightforward and simple. And what we found is that once you get past a certain number of values, it falls into that normal curve. And since it falls into the normal curve, I can use exactly what we've been doing with the z-scores and everything else to find the probability and the percentages. So the first thing we need to find to be able to do any of this is we need to figure out our standard deviation and our mean. We need those two pieces of information. Okay. So if we look back at these formulas, we can use these to figure out the standard deviation and the mean. So mean in this case is N and P. So those are the two pieces of information I need to know. And this problem, oh, they didn't give you the N in this problem. That's right. The N was the piece that changed. So we're going to assume N was, what did we figure out? 18 was the number that we, if I remember right, was the ideal number. All right, so we'll do 18. So N was 18. And what's my P? Point 20? Do we want them to not show up or to show up? We're gonna look at the people who showed up, right? So we want show up. So it's gonna be 80. So my P is 0.80. So my mean is 18 times 0.80, which is what? It's 14.4. Okay, so let's take a step back. Everybody understand where I got? So I made up the N. Does everybody understand where the P came from? Okay. Everybody understand how I found the mean? The mean is just N times P. Because to do everything we've been doing this week, past couple of days, we have to have the mean and the standard deviation. Because the only way for us to find the z-score is with those two pieces of information. So this one, these formulas give us the mean and the standard deviation. So they're not going to be necessarily given to us in the problem. We're going to have to find them. And that's these two formulas. So my standard deviation is the square root of 18 times 0.8. And what's the 1 minus the P? That's the 20. Remember, what do those two numbers always have to add up to? Those numbers have to add up to 1. And I get 1.70 is my standard deviation. All right. Are we good to that point? Everybody get those two numbers? We're good? We're not done, but are we good with that? All right. So now that we have those two, if my X is 15, we want to know what's the probability that I'm going to have to bump somebody from the plane. So I would want greater than 15, correct? Okay. So how many people would that be? If I sold 18 tickets, how many people would that be? If I'm going to bump somebody from the plane, how many would have to show up? 16, 17, or 18, right? Yes? Okay. Everybody got that point? Okay. So can I have 15.1 people show up? No. So now we're starting to see a problem with when we look at it in terms of a continuous stretch, which is what we've been doing, right? That bell curve is continuous, correct? So because if I said anything greater than 15, I'm going to include everything 15.1, 15.2, 15.3, all those values in there. So what we do to be able to use this method to do it, we have to do what's, we basically have to have what they actually have a word. Hold on. Find the exact word they use. A continuity correlation or continuity correction. Sorry, correction. So instead of doing it at exactly 15, we're going to use 15.5 because I want bigger than that. Okay, so 15.5 would represent the 16 number. But I want 16, so I want to be a little lower than that. So they always break it in halves. Okay, so we're not going to use X as 15. We're going to set it to 15.5. Okay. Yes, no. Makes sense? Okay. So we're at my X, yes.
Could we set it to 31/2?
Yes, but that's going to make your life harder.
Okay.
Remember, when we're looking at the z-scores, we're going to get decimals anyway. So yes, when we're looking at percents and stuff or probability, fractions are generally better. But in this situation, we're going to go into decimals anyway. So keeping it as a decimal makes a lot more sense. Okay. All right. So find me my z-score. So my z-score should have been 0.6. Yeah, 0.647. And remember, my z-scores I always round to two decimal places. So 0.65. All right, so what's my percent that goes along with that z-score? Okay. So 0.7422. I wanted, that's less than, right? I wanted greater than the 15, right? So I have to do 1 minus that. So 0.2578. Okay. So that's my percentage. That'd be the chance that I'm going to take to have to bump a person. It's just over about 26%. When we did it last week, we got 27%. So it's a little higher. This is a little lower, but it's within reason. And this is easier to do because it standardizes it. So it would one way to do them all. And the nice thing about this method is while looking at 15 people out of 18 isn't a lot, when we have to start looking at larger numbers, this method makes a lot more sense for us to work with. Okay. Yeah. This is the method most of them actually, the computers actually end up using to do the calculations anyway. So. All right, let's do this one. All right. So N is 20. P is 0.5. Find my mean and find my standard deviation. So what's my mean? Yep. And what's my standard deviation? Yeah.
0.24.
Yes.
Rounding down.
Yeah. All right. So what's the probability that it's 5 or less? So what's the X value I'm going to use for this?
Five.
Not 5. Yes. I want 5 or less. So I want to include the 5. So I have to go a little bigger than it. So I go to 5.5. Okay. So when we're looking at our curve, if I want, so let's say my 5 is there, right? I want to include that line. So I need to go a little bit higher. So this way my shading would include that line. Okay. You could technically use any number you want. However, they standardized on a half. So it's kind of one of those things like it was more like exactly. It's like, okay, can I use one or point? But then it's like, okay, can I use 0.01 or 0.001? It's like the closer you get more accurate. So it's like, okay, just to make life simple, we're going to do a half. It's basically what they decided on. So, yeah. Because remember, the formula for standard deviation is P times 1 minus P. In this case, since P is 0.5, 1 minus 0.5 is also 0.5. Yeah. Yeah.
This might be splitting hairs, but who is that in that?
Mathematicians in general, when they first came up with it. It's just like who came up with PEMDAS? Why do we do it in that order? It's like we could just do it from left to right. That would make sense, except the entire world doesn't read from left to right. So we had to standardize on something, and that's what they came up with. That was a standardized way of doing it. So people way above my, well, people that are dead now, but way above where I was. All right, so that's my X, so find my Z. So we got negative 2.01. All right. So what's the? Oh, sorry. Actually, we just found out. So 0.20222. We should have gotten. All right. Yeah, I'm gonna skip that. All right. Let's look at this one. Okay. Find me my n. Find me my p. My mean, and my standard deviation. NP means standard deviation. So n was 1,000. P was 0.20. The mean was 200. And the standard deviation is 12.65. Yes.
Why would it be, 0.20 and not 0.15 when, because they were saying that they claimed that it was 20%, but what they actually found was that only 150. So,
So, because their claim is that 20% new. And that's what you're trying to show.
okay,
Right. You're trying to show that that claim is true. All right. So what's my z-score for this? Hold on. We can't use 150. What number should we have used? Almost.
145.
150.5. Because we want 150. So we're just a little above it. And this one, realistically, it doesn't make that big of a difference.
Negative.
Yes. Because 150 is less than the mean. So you're going to be on the negative side. Okay. So what's the probability that that would be true? Right. It's not even on your sheet. So it's basically 0. So if the agencies claim that 20% of the alumni were aware of the new campaign were true, then they should have expected to find more than 150 people. Okay. So their claim was wrong. So now you can actually start to see how we can use this to start determining if claims are true or false. That actually leads us into hypothesis testing, which is the basis of the main part of statistics, which we're going to be looking at after the test next week. All right. Okay, find me the answer. So how are we going to go about doing it? Yeah.
Would it be 0.05 equals x minus 700 all over 100? Or the x minus 700 be over 100?
So the X is 5%.
So the x would, so the z score, oh, no, I didn't find the z score. The z score of the, oh, no, I'm wrong.
What do we, so, okay. So the question is, and this is what's going to be like on your test and everything else next week. It's like problems are going to look very similar. You need to look at the problem and say, what are they asking you for? So what is the answer asking you for in this problem? Are they asking you for a percent? Are they asking you for a value? So
Number of days that
So they're asking, they give you the percent. They're asking for the number of days. So they're asking for a value, not a percent. So in essence, they're asking you for X. They're asking for that. Okay. The next thing you have to ask yourself is this a binomial thing or is it just a normal distribution? Do they give you a percent and a, do they give you N and P or do they give you the standard deviation and the mean? Right. So it's a normal curve. We don't have to, it's not that discrete binomial expansion that we were just talking about. So they gave me my mean is 700 and my standard deviation is 100. And they gave me my percent is 0.05. So I need to find my Z. So what would be the, I want no more than 5% batteries to fail. Yeah.
I got negative 1.64. I mean, because it's kind of caught between 0.5 and 0.495. So
Yes. Okay. So you could either do one for that or that, because it's like basically right in the middle of the two of them, right? In actuality, this is not something you would have known before now. We actually, since it's exactly in the middle, we split the difference. So you could actually use 1.645 for your Z. And is it positive or negative? Negative, because we want the low end, right? We're talking about what's the earliest they could possibly fail. So we want the negative side of it. Okay. So I've got negative 1.645 equals X minus 700 divided by 100. So what do I do? So negative 164.5. So 535.5 equals X. So how many days? Yeah. So you look at your table and we're looking for 0.05. So it ends up being between, you end up getting 0.0505 and 0.0495. It's like right in between those two. So we literally split the difference between them because it's exactly on both sides. You could have used either one of those and it would have been fine. As we go further in the class, that number is going to become a very important number for us to use. That one's going to come up quite a bit. So how many hours would you tell me that the battery is going to last? or yeah, sorry. And this is days. So how many days? I would go down. I'd say 535. But honestly, if somebody's giving you a warranty, are they really going to say 535 days? They're going to say probably 500 or a year and a half. Like they're gonna give it a lot easier than that. So I probably would say 500 days, and nobody's going to bring them back because I know it's not going to happen. So we see that all the time, though, right? When you think about it, you go out and buy something and there's a warranty on it that says, oh, this is going to last. It's the warranty, the manufacturer warranty is 18 months and it fails at the 19th month. Because they plan that. They know when these things are going to fail and they make sure that they give you a number that's just below where it's going to start to fail. Okay, so if I said 500 days and it failed at 510, you can't come back and complain. It lasted the 500 days I said it was going to last. So, all right. The review test is online. I can't remember how many questions it was. I think it was 14. There's 18 parts to it. Most of the questions are from chapter 8. There are a couple questions from chapter 6, a couple questions from chapter 7. So, but most of them are from chapter 8. So, review. If you think you're good, I don't need to see you necessarily on Monday. But as evidence from the last test, the ones who really practiced the test and practiced and did that did very well on the test. Ones who didn't do so well on the test. So make sure to practice that test. Do it as many times as you want. Monday we'll go over the test, and then Wednesday will be your test. Huh? Oh yeah, no, go. You're fine.